These are algebra notes for section 7.2, where we are going to look at geometric sequences. So where it says let's review, we're going to review something we've already done this year, and that was arithmetic sequences. So when we had arithmetic sequences, we looked at how those numbers in the sequence change from one to the next. So how did we go from 3 to 4.5, 4.5 to 5, we added 1.5. 4.5 to 6, we're adding 1.5. Every time we are adding 1.5. So that's what we called our common difference. And the first term in this sequence was 3, and then we always were asked to find the next amount of numbers. So we would have, after 9 would be 10.5, then 12, then 13.5. So we're going to fill those numbers in, 10.5, 12, and 13.5. And so arithmetic used addition and subtraction. Now, in this lesson, we're going to study geometric sequences. And geometric sequences are an ordered list of numbers that form a pattern with a common ratio. So instead of common difference, we're going to use a common ratio. And what's important to note here is that this is going to use multiplication. Which will sometimes feel like division. Okay, so our first example, we have 2, then 4, then 8, then 16, then 32. So we're going to multiply each previous number times 2 to get the next number. If you were talking to your classmate and they said they didn't understand what the difference between the two types of sequences were, what would you say? So arithmetic sequences, these use addition and subtraction. We call it a common difference. To go from one to the next. And a geometric sequence will use multiplication. And we call it a common ratio. The common ratio takes me from one output to the next. Okay, so our first example, we go from -3 to 6, 6 to -12, -12 to 24. So we're multiplying by -2. So that's my common ratio. And the first term in this sequence is -3. And now our next term, 24 times -3. So a positive times a negative is negative. And, oh, why did I said -3? I meant to say -2. So we're multiplying by -2. 24 times -2 would be -48. When I multiply that by 2, I'm going to get positive 96. And when I multiply that by -2, negative 192. Now on the next one, these numbers are getting smaller and it feels like division, but we're actually multiplying by 1/5. So if it feels like you're dividing by 5, you're actually multiplying by its reciprocal. So our common ratio here is 1/5. Our first term is 125. And these numbers get small, so we go from 1/5 times another 1/5, giving me 1/25. And then I'm going to multiply 1/25 times another fifth. So 1 over 125. One over 125 times another fifth would be 1 over 625. Okay. Now this next one is presented to us on a graph, but what I want us to do is look at that graph and make an ordered pair list or a chart. And I can see, let's see, it looks like every box is counting for 18. So 36 plus 18 would be 54. 72 plus 18 would be 90. Plus 18 would be 108. Plus 18 would be 126. 144. 162. Okay, we want to see what are these ordered pairs. So looks like I'm at 1 and 0. Maybe. Is it easy to tell that? I can't really tell that. I can tell. Let's put a spot for 1, a spot for 2. Can I tell where 3 is? It looks like 3 is exactly on 18. 4 is exactly on 54. 5 is exactly on 162. So to go from 18 to 54, I'd have to multiply by 3. And to go from 54 to 162, I'd multiply by 3. So I want to figure out what number went here that when I multiplied it by 3, I got 18. And that number would be 6. And then what number would be here that when I multiplied it by 3, I got 6, and that number would be 2. So our common ratio here, we kind of looked backwards. Our common ratio was a 3. Our first term was a 2. And our next terms, and I'm reaching for my calculator on this one. Let's see. I've got 162 times 3, so 486. And then I'm going to take that one, I can hit the answer button, times 3 will give me 1,458. And for my next answer, I'm going to hit that answer button, times 3, 4,374. So these numbers are going up high really quickly. Now we have two types of formulas, explicit and recursive. G of n, we're going to remember that n can be any number, the number of the term you're solving for. So if you see G6, it's asking for the 6th term. G1 is the first term. That n is the nth term, and r is the common ratio. The recursive formula is used to find the next term. G1 is going to be the first term, n is going to be the number of the term you're solving for, and r is the common ratio. So those are consistent across both. You just need to know, it's helpful to know the difference between explicit and recursive. So it's like if your parents said, I explicitly told you to pick up your shoes. They wanted you to do exactly that. So the explicit formula wants you to find that exact number. So let's do these few examples. We've got 8, then negative 16, then 32, then negative 64, and it looks like we are multiplying by negative 2. The first term in my sequence is 8. Write the explicit formula. So I'm going to use that formula up top, g of n equals g of 1 times r to the n minus 1. So it really helps me to write that formula. Okay, this is a time where we'd say WTF, guys. So g of n equals g of 1 times r to the n minus 1. And when we plug that in, or substitute those numbers, g of n will stay g of n. G of 1 is 8. Negative 2 is my r value. So times negative 2 to the n minus 1. And when we are asked to find the 25th term, we're going to say n equals 25. So I'm going to take that formula we wrote and put g of 25 equals 8 times negative 2 to the 25 minus 1. So I'll simplify that first. G of 25 equals 8 times negative 2 to the 24. And I'm going to use my calculator, and you have to be really careful because you're not going to hit enter. Do not hit enter till the end. So do not hit enter until you type it all in. Because if you did that, you would be ignoring order of operations. And order of operations tells us that we have to evaluate the exponent first. So when you type this, you're going to type in 8 times negative 2 exponent 24. So that's giving me a super big number. And you know what? I meant to put this in parentheses. Let's see if that negative 2. And that did make a difference. So g of 25, because a negative raised to an even power is going to be positive. That's how I knew something was up there. So make sure if your base is negative, you put that in a parentheses. 134, 217, 728. And that's a big number, but it's also raised to the 24th power, then multiplied by 8. So that explains why that number is in the hundreds of millions. Okay, our next one, our common ratio, looks like we're multiplying by 2. 4 times 2 is 8, times 2 is 16, times 2 is 32. So my common ratio is 2, that's my r. My first term is 2, that's my g1. And our formula is g of n equals g of 1 times r to the n minus 1. So g of n equals my first term 2 times 2 to the n minus 1. And now we're asked to find the 11th term. So g of n, equals, and let's actually, instead of g of n, that should have been g11, equals 2 times 2 to the 11 minus 1. So g11 equals 2 times 2 to the 10th. So be very careful that you're not doing 4 to the 10th because that's going to be a different number. So when we type this in, 2 times 2 exponent 10, and that's 2048. So g11 equals 2048. Our last example has a pendulum swinging, and it swings the farthest on its first swing. So first it swings 80, then 76, then 72.2, then 68.59. So these numbers are getting smaller. And if I made a table out of them, I'd say, okay, my first swing, it went 80. My second swing, it went 76. Third, it went 72.2. Fourth, it went 68.59. So we need to figure out how much smaller is this getting. So if it was linear are easier to see. Exponential can be when you're multiplying by numbers you're used to, like a half or 3 or just really common numbers. But I don't know what I multiply 80 by to get 76. So what I want to do is find a common ratio by saying, okay, well, the second swing is what percent of the first swing? So the second swing is 76, but the first swing is 80. And we want the decimal value for that. So 76 out of 80. And when we get that, we're getting 0.95. So that means we're taking that first swing and we're multiplying it by 0.95. So it's getting a lot smaller. If that were a fraction, it would be 19/20ths. But we'll go ahead and use the decimal 0.95. So let's see. If the pattern continues, what explicit formula can we use? Again, explicit formulas are those ones that give you a number for a very specific number in that list. So g of n equals g of 1 times r to the n minus 1. So g of n equals g1, which was 80, because that was our first swing, times 0.95 to the n minus 1. So that's my equation. Now it wants us to know, where's it going to be on the 10th swing? So g of 10 is equal to 80 times 0.95 to the 10 minus 1, which we know is going to turn into 9. So g of 10 equals 80 times 0.95 to the 9th. So remember that when you do that, you're doing 0.95 times 0.95 times 0.95 9 times, and then multiplying the output by 80. But our calculator will show us 95 to the 9th. So g of 10, we're going to say, is about 50.4. And we're going to put that centimeters label on it. And that should be all. I'm pretty sure there's a question like this on on the homework assignment. So make sure you are finding that correct value by putting the second output over the first output. And you're basically finding that percentage, which gives you that change.